Hello everyone, I am Ghanshyam and welcome all of you to the electric neuron. Today we are going to discuss about the nodal analysis in the network theory. Those are very important to your examination like GATE, ESE, RRB, JEE, SSC, JEE and assistant engineering examination. And also it is very important to your university examination to write the basic of the network theory question or problem. Okay, so in the previous lectures we have already discussed about the mesh analysis and we have already solved some problem on the mesh analysis. So in this video we are going to see what is the nodal analysis, why we require this nodal analysis. Okay, so before starting our video lectures, I want to tell you that if you like the video, please share to your friend and also subscribe to this channel so that you will get immediate notification whenever I will upload a new video. Okay, so let's get started our video. So see this nodal analysis, why we use the nodal analysis. See, our electrical network is very complex in nature. So to solve the complex nature of the electrical network to a simplified manner by using the Kcl, Kvl and basic Ohm's law, we need nodal analysis and mesh analysis. So in the mesh analysis we consider the loop concept. By using the Kvl equation only we solve the problem. But here in the nodal analysis we used to see the node of the figure. Okay, so let's read all those things. Nodal analysis can be applied for a planar and non-planar network. See, in the mesh analysis we have already discussed that our mesh analysis is only applicable for the planar network, it is not applicable for the non-planar network. So in this case in nodal analysis it is applicable for both planar and non-planar network. So I have already told that planar network, which one is the planar network? Those network which consisting of only one circuit which is not overlap with the another circuit, those network is called the planar network. And which one is the non-planar network? Those network which is overlap with the another network, so another with the another the node, then it is called non-planar network. So the node analysis is applicable for both the nodal both the planar network and non-planar network. Remember that point. This is the main basic difference between the mesh analysis and node analysis. Okay, so let's see the procedure for the nodal analysis. So first identify total number of node in the given network. So in the mesh analysis what we have to do in the first procedure, we have to do that how many mesh or how many loop in the system. So we have to find the loop in the system in the mesh analysis. But here in this case identify total number of node in the given network. See, in this network this is the node, this is the node, so there is only two node connected at a network. So at one node there is a 3 branch connected with each other, and here also at another node there is a 3 branch connected to each other. Okay, so its first procedure is to identify the total number of node in the given network. Okay, and the second procedure is not second procedure, it is the second point. Okay, so assign the voltage at each node. One of the node is taken. So first assign the voltage at each node. So there is two node only, this is one node, this is two node. So assign the voltage across the node, that means V1 is the across the node 1, V2 across the node 2. Okay, so now then the node is taken as a reference node. So you have to choose any node as a reference node. If you want to choose this node as our reference node, then you can also choose this node as your reference node. Okay, so reference node and reference node potential should be equal to 0. So here in this case we are taking this node as our reference node, that's why V2 is equal to 0. Okay, now see the third point, develop Kcl equation at each non-reference node. So this is our reference node, that means the opposite sign that node is our non-reference node. So here we need to apply the Kcl or Kvl equation and we need to find the non-given quantity. Okay, so after developing the Kcl equation in the reference node, we proceed toward the point number 4. So by solving the Kcl equation, find the node voltage. Okay, so after finding the node voltage, whatever the non-given quantity are given, that quantity are to be calculated. Okay, so in node analysis total number of equation like as our mesh analysis, Total number of mesh is equal to total number of equation. Here also total number of equation is equal to number of node minus 1. Okay, see there is 2 node, node 1 and node 2. So 2 minus 1 is 1. So there is one equation only exists in this network. Okay, so let's see. Okay, see here this is our non-reference node. So here put the Kvl equation. That means V1 minus or Kcl equation, V1 minus 4 divided by 1, that is current flowing across this. Okay, V1 minus 4 divided by 1, like that. V1 minus 2 divided by 1 is the current flowing across this. Okay, because of by only applying the Ohm's law. Okay, like that here 2 ampere current will be flowing, so no need to write the V1 minus something that like that. So here 2 ampere is equal to 2 ampere. Okay, so after calculating this to V1, that means V1 plus V1 is equal to 2 V1, and 4 minus 4 plus 2, that is minus 2, and in the right hand side 2 is left, so that 2 is here. And after calculating, that means minus 2 will be transforming to this side, then minus 2 will be plus 2 here. Okay, so plus 2 and plus 2 is 4, and 2 V1 is in the left hand side. So after placing the V1 here only, then 2 will be transferred to the right hand side with the denominator. Okay, so 4 divided by 2 is equal to 2 volt. Okay, so this is your answer. This is your last procedure to find the voltage across the non-reference node. Okay, so all those points are clear to you. If it is not clear to you, then ask me in the comment section, I will clarify your doubt. Okay, so now see some problem on the mesh analysis. This is one problem. Here voltage source, 2 voltage source, 3 voltage source, voltage source 1, voltage source 2 and voltage source 3 are connected parallelly with the resistance R1 and R2, and this resistance is connected with the R4 resistance. Okay, so there is how much node? Please calculate that. This is one node, this is another node, this is another node, 3 node, with this is another node, 4 node. Okay, so put the voltage equation across the node, that is V1, that means node across voltage V1, V2, V3, V4. Okay, so number of equation is equal to, we have already know the formula, that is n minus 1, that is node minus 1, that is equal to node is equal to 4, 1 2 3 4. Okay, 4 minus 1 is equal to 3. So here 3 node will be, or 3 equation will be possible in this circuit. Okay, so it is not asking about to find anything else. So let's see some point of this. For knowing the value of V1, V1 and V2, we don't need Kcl equation for V3, we need to apply, but for V3 we need to apply. See, why? Because of this V1 is that voltage source Vs1, same here. Okay, like that here also V2, same voltage source. Okay, so here no need to apply any Kcl or Kvl equation, but here in this case there is no voltage source connected with the V3, so that's why we need to calculate the Kcl and Kvl equation here only. Okay, so if you want to find the Kvl or Kcl equation, then you can also find here, but we are not going to that because of the time issue. Okay, please note that to find the node voltage in the above network, minimum one equation will be required, like that our mesh analysis. Okay, let's see another question. Find resistance R when Va is equal to 4 volt. Okay, so this is our network, 12 volt is series connection of 6 ohm resistance, and here R is parallel with the network and 2 ampere will be also parallel connection with the network, and here 8 volt with the 3 ohm resistance. So here 4 volt of Va is given, but he is asking about to find the value of resistance R. Okay, so here apply the Kcl. Where? This is one node, this is another node. So in this node we are taking the reference, and it is the non-reference node. So in the non-reference node we need to apply the Kcl or Kvl equation. So put the Kcl equation here, that means Va minus 12 divided by 6 is equal to current across there, and Va divided by R is the current across this, and this current is 2, so here apply 2, and Va minus 8 divided by 3, so current across this, okay, equal to 0. So Va value is given 4 volts after applying the 4 volt in the Va point and equating to 0 in the right hand side, then 4 minus 12 is minus 8 divided by 6, and this is 4 divided by R, and this is 2, and this Va 4 minus 8 is minus 4 divided by 3, so this is cancelled by the 2 into 3 divided 2 into 4, 4 divided by 3, and this is minus 4 divided by 3, so this is also minus 4 divided by 3, this is also minus 4 divided by 3, that's why minus 2 into 4 divided by 3 plus 4 divided by R as it is, and 2 as it is, equal to 0. So minus 2 into 4, that is 4 into 2 is 8, so minus 8 divided by 3 plus 2 plus 4 divided by R equal to 0. So after calculating this, 3 into 2 is 6, minus 8 plus 6, that is minus 2 divided by 3, okay, and minus 2 divided by 3 plus 4 divided by R equal to 0. So 4 divided by R, and taking this minus 2 divided by 3 as our right hand side, so after calculating this we will get R is equal to 6, okay. So it is asking about to find the value of R, we got the value of R. So this is your answer. By applying only the node analysis, it is very simple to calculate the unknown value, okay. So now come to the another question. See, this is the another question to it is asking about to find the value of R1 resistance and R2 resistance. See, this is the R1 resistance and this is R2 resistance of the network sun corresponding to the node 4. This is node 4 which is taken as a reference, and other are non-reference. So there is 1, 2, 3 node are non-reference node, okay. So the number of equation, possible number of equation is node minus what, 1. So put the node minus 1, 2, 3, okay. So node minus 1, that means 3 minus 1 is equal to 2, so there is 2 possible equation will be formed, okay. So here 100 volt is given, 40 volt is given, and 2 ohm resistance is given with the 14 ohm here also given, and the current direction with the current value 10 ampere, and here 5 ampere with the direction value is given, okay. So here 10 ampere and here 5 ampere is given, so that will be come to the this side, it is not going to upper side, and by the Kcl only this current plus this current is 15 ampere, so here 15 ampere current will flow, okay. So here if you want to find the voltage V2, then multiply the current with the resistance, that means 15 with 2, 15 into 2, that is equal to 30, so V2 is equal to 30, okay. So now apply the Kcl equation in the node 1, this is our node 1, so apply here Kcl equation, that means this is 10 ampere current will be flowing like this, so 10 ampere is equal to this voltage V1 minus V2, this voltage divided by 14 is equal to current across here, and V1 minus V3 divided by R1 is equal to current across here, okay. So this is first equation, and across the node 3, so first we need to solve this one. So see, there is V1 is given 100 volt, so 100 volt, and V2 is also given 30 volt, not given, we have already calculated this one, so this is 30 volt divided by 14 minus V1 given, that is 100, and V3 also given, that is 40 volt, okay, divided by R1. So this is only one unknown quantity are given, only one unknown quantity is left there, so that's why it is very simple to calculate. So R1 is equal to our 12 ohm, okay. Now see the node 3, this is our node 3. So apply the Kcl equation here. Also that 5 ampere current will be flowing like this. So 5 ampere is equal to V3 minus V2 divided by R2, that is 40 minus 30 divided by R2. Okay, 40 minus 30 divided by R2, and another equation will be that is 40 minus this 100 divided by R1. Okay, so here 40 minus 100 divided by R1 is 12. We have already calculated here, R1 is equal to 12. So here only unknown quantity is R2. So it is very simple to calculate. So after calculating this, we will get the value of R2 is 1 ohm, okay, and R1 is 112 ohm. Okay, so it is quite simple. Okay, this is your answer. Now come to the another question. It is asking about to find the V1 and V2 of the network sun. So this is the network with the connected with the 10 ampere resistance, 10 ampere current sources with 1 ampere resistance parallel connection. Here also 5 ampere current sources with the 1 ohm resistance, and there is 1, 2 and 3. There is 3 node. Okay, so for node 1 and node 2 we need to calculate the voltage V1 and V2. So please note that when ideal sources voltage sources is connected between the two non-reference node, that means it is our reference node, so voltage across this is 0, and those two nodes are our non-reference node. So if ideal voltage connected between the two non-reference node, it is possible to find the solution by using supernode technique. Okay, in the mesh analysis also we have already discussed supernode concept. So here also we need to apply the supernode concept. In the supernode concept we apply Kcl, Kvl with the help of Ohm's law also. Okay, but in nodal analysis only Kcl plus Ohm's law will be existable. Okay, so see, so here put Kcl equation, that is this is the our 5 ampere flowing like this, and the 10 ampere flowing like this. So 5 and 10 equal to V1 divided by 1 plus V2 divided by 1. Okay, because of the current across here and current across here. And this is another equation, V1 minus V2 is equal to 2, because of the potential difference across the two nodes, that is equal to 2. So from this equation only V1 is equal to 2 and V2 will be transferred to the right hand side, that is why 2 plus V2. Okay, so now from this equation only V1 plus V2 is equal to 15. See, V1 plus V2 is equal to 15. Now put the V1 value here in this equation, that is 2 plus V2. 2 plus V2 plus V2 is equal to 2 V2 plus 2, and 2 will be transferred to the left hand side, that means minus of 2 will be there. So 15 minus of 2, that is 13. 13 is equal to 2 V2. So 2 V2 is equal to 13 and V2 is equal to 13 divided by 2. So value of V2 will be got, that is 13 divided by 2. Now put the value of V2 in this equation. Okay, so after putting the value of V2 we will get V1 is equal to 17 divided by 2. This is our solution. Okay, now see another question. So it is also asking about to find the V1 and V2 of the circuit sun. This is the V1 and this is the V2. This is one voltage sources with the resistance, this is one current sources with resistance, this is one resistance, and this is another one resistance. So here we are taking this node as our reference node and this is our non-reference node. V1 and V2 is our non-reference node. So apply Kcl or Kvl in the equation in the node V1 and V2. Okay, so first apply the Kcl, because V1, okay, V1 minus 2 divided by 2 is equal to V1 divided by 2, and V1 minus V2 divided by 2, that is equal to 0. This is equation number 1. So after calculating this, 2 will be transferred to the right hand side equal to 0, and V1, this V1 and this V1. Here is 3 V1 minus 2 is equal to only V2 is there, so that's why we are transforming V2 is our right hand side. So 3 V1 minus 2 is equal to V2. Like that, put here in the node 2 Kcl equation, V2 minus V1 divided by 2 plus V2 divided by 2. This is our 2 ohm resistance, and in the right hand side it is 2 ampere current flowing, that's why we are taking at the right hand side 2. Okay, so after calculating this, 2 V2 minus V1 is equal to 4. Okay, so now transfer this V1 to left hand side and this V2 to right hand side, then we will get this equation. After getting this equation, we need to apply the V1 value here. Okay, so 3 into 2, 3 2 is 6, 6 V2, 3 into 4 is 12, 12, and minus 2 is here as it is. Okay, and the right hand side V2 as it is. Now there is one V2 and there is one V2, so V2 will be transferred to the left hand side, then minus V2, so 6 V2 minus V2 is equal to 5 V2. Okay, so 5 V2 is equal to minus minus plus, it is 14 right hand side. Okay, and V2 is equal to 14 divided by 5 is equal to 2.8. If V2 will get 2.5, then put here 2.5 value, 2.8 value, then you will get V1 is equal to 1.6. Okay, so this is your actual solution. Okay, like that you have to calculate all those things. Now see another question. When a practical DC sources of 3 voltage with the internal resistance 2 ohm. See, this is the practical voltage sources 3 volt with the internal 3 ohm resistance connected to a non-linear resistance. This is one resistance which is non-linear in nature, and the characteristic of non-linear resistor is given by VNL, voltage across the non-linear resistor, is equal to INL square, that means current ka square. Okay, or VNL dash is equal to voltage non-linear, INL is equal to current non-linear. Okay, so we need to find the current non-linear current. So apply Kcl equation here, that means 3 volt is equal to 2 into INL plus INL square. Why? Because of the VNL is given INL square in the question. Okay, so here INL square plus 2 INL minus 3 equal to 0. So see here 2, here 3, so 3 minus 1 is that 2. Okay, so after calculating this equation only we will get INL is equal to 1 and minus 3, but here current is not minus 3 in this, not in this direction, only in this direction, that's why we are taking the 1 value only, we are not taking minus 3 value. So VNL is equal to INL square is equal to 1. Okay, so we will get current should be positive only, that's why 1 is our answer, and power is INL into VNL, that is 1 into 1, that is equal to 1 watt. Okay, so this is your answer. So far we have already discussed the mesh analysis. In this video we have also already seen all the theory and the procedure to find the nodal analysis, and we have discussed some problem related to the nodal analysis. So if you have any doubt, please ask me on the comment section, I will solve here or rectify your query. Okay, for today that's it. Thank you for watching.